Boy, that nebula looks beautiful in my telescope here. Hey, everybody. I'm Marquette. So glad that you're welcome here with us today. I'm up on top of White Top Mountain, sort of, but let's say I'm in my backyard. Welcome to my backyard, as I'm Stargazer Mark, and I'm so glad you joined us to stay star curious today on Stay Curious. As I got my red flashlight, there it's working, so I can see my charts under the night sky and not dilate my pupil. They stay, so they do stay dilated and they don't contract out. That's what red light does for you. We've got a nice little show to you about what's up in the morning sky and in the evening sky and an eclipse of the moon coming up. But I'm looking through this big 11-inch telescope here. I'm going to shove it off to the side there so Marty Winkle, my cameraman and co-producer, can do our thing on our Streamlabs production facility here at the American Space Museum. This first week of May finds us in a wonderful transition from the winter constellations you were so familiar with are now setting in the west and rising in the east. There's not as many bright stars because we're looking out away from the Milky Way galaxy, and there's an expanse of galaxies that we're looking at as we kind of looking out of our planet, off our planet, off of our own galaxy towards other galaxies. And in Virgo, Leo, and Ursa Major are major, many, many thousands of galaxies, just like our Milky Way, teeming with stars that all have, most of them have planets around them. And who knows who's looking back, right? Well, Sunday, this is May 2nd. Yesterday was new moon, which means the moon was very close to the sun, visible, invisible all day long in the daytime sky. But 2 weeks from Sunday, we're going to have an eclipse of the moon, where the full moon is going to go into the Earth's shadow, and we'll have a program all about that on our Stay Star Curious Backyard Astronomy next Monday, so make sure you catch that. And in fact, we've got a great list of programs for you all week here on Stay Curious, so check them out. And if you missed the date time at 4 o'clock Eastern Daylight Time, that we have them on our YouTube library, our Facebook library, Twitch, and Spotify. And we thank you all for watching us. Please tell your friends if they want to learn a little bit about astronomy and what to see in your own backyard, to like us, share us, follow us, or subscribe to us. This is a beautiful image taken from the top of near Damascus, Virginia, which is close to the border of Tennessee, up there in that little area that butts into Virginia and North Carolina, where I lived for over 30 years, in Bristol and Johnson City. And my good friend George Fleener took this beautiful picture of the stars coming out over one of the familiar stargazing spots for me up on White Top Mountain. So thank you, George. He's into selling planetariums and quite an avid astronomer. Tonight, you have the opportunity on Monday, May 2nd, to see the thin crescent moon very close to the planet Mercury. And joining the scene is the star cluster, the Pleiades, the 7 little sisters that we've talked about on our show. Well, I'm going to show you an image here that you're not going to believe. This image is, wait, there we go. Let me bring it up there, Marty. It's not coming. There we are. Whoop, I had it. There we go. What looks like the Pleiades and a comet in the sky is not a comet. That is the planet Mercury with a sodium tail that is incredibly photographed by a Dr. Sebastian Voltmer in the Canary Islands. Now, it helps being in the Canary Islands to have super dark skies to get that nebula in this photographic exposure around the Pleiades star cluster. Those 7 stars have been born together out of a cosmic cloud, and just some of the cloud is left. But below it, Marty, that's not a comet. That is the solar wind and micrometeorites ejecting sodium atoms from the surface of the planet Mercury. This creates a yellow-orange tail of sodium gas that is around about a million miles long, over 2 kilometers, so it'd be about 1.5 million miles long. and this amateur astronomer photographed it. You cannot see this with your naked eye. You need a special sodium filter called a 589 nanometer filter to allow you to see the sodium glow there. And without that, the tail would be invisible, but you'd still see Mercury. Mercury bobs up and down the horizon either after sunset or before sunset 4 times a year as it orbits the sun every 88 days. So it's now at what we call a favorable evening apparition, and it's going to be close to the moon tonight, and the Pleiades are there, and I'll bet this Dr. Voltmer will be having his sodium filter on that to get another spectacular image that I got on spaceweather.com is a great resource to watch and look at regular photography that people are doing with just telescopes, camera lenses. Even you'll see some smartphone pictures on there once in a while on spaceweather.com. We'll feature that one day. But a lot of you have been getting up early. Those of you early risers, and I'm not, but I've got up early a few mornings to see the planets in alignment. Remember last fall we had Jupiter and Saturn and Mars, and we're in a nice lineup, and Venus. But they all shifted as the Earth moves around the sun. All that shifted to the morning sky. And what we see here on the beach up at India Atlantic, about 35 miles from where we're sitting here at the American Space Museum, as the stars and labeled here. Whoop, let me go back there. Labeled, you've got Jupiter, Venus, the Moon, Mars, and Saturn, all lined up in this beautiful photograph taken by my astronomy friend Mark Poole. Good job, Mark. There you got the ocean, and you see the moonlight reflected in the ocean. And there you have 3 planets and the moon. That was last week. And then the next night, the crescent moon is below Venus and Jupiter. And as I'm looking at these objects, I look at them and I'm going, wow, we know these worlds have real surfaces, but the ancients for centuries and thousands of years just watched them line up, follow each other around, get close to each other as the moon played tag with them, and therefore all of these stories and mythologies and theories were evoked. And then the modern era with the telescope, we figure out exactly what's going on. Here's a friend of mine, another astronomy buddy, Gil Pulmer. He photographed Jupiter and Venus very close together, and they're still getting close together in the morning sky. So get out and watch it as the planets are moving away from each other in their own orbits as the Earth goes around the sun. But let's look at them up close. There is what Venus actually looks like. Venus is always going to be the 3rd brightest object in the sky, next to the sun and the moon, and the 4th brightest object will always be Jupiter. Though Venus is covered in clouds, this is the Magellan spacecraft, a map that it made of Venus. The colors correspond to blue being not oceans, but low areas. There are no oceans on the 900-degree surface of Venus, and the tan areas are the highest areas. Though those high areas don't get as high as just a couple miles. This hot runaway greenhouse effect on Mars, Venus, has basically melted everything down. You can imagine it would melt lead at 900 degrees. So the rocks are soft looking when we go to the surface. Magellan was launched in 1985. STS-30 put it into orbit. We're going to be celebrating that on May 4th, 33 years ago. 1989 it was. A 6-year mission of Magellan was deployed by the astronauts on the space shuttle. And that'll be May 4th, and we'll be talking about that on Stay Curious. And here's a current shot of Jupiter in our morning sky with the red spot on the side. Look at these. We're looking at the cold, through 200 below zero cloud tops of ammonia and methane and hydrogen on Jupiter, as seen from the current orbiting Juno spacecraft. this Juno spacecraft is quite extraordinary because it goes out 2 million miles from Jupiter and then dive bombs in to less than 2,000 miles above the surface. And when Jupiter gets into the evening sky and we're looking at it through telescopes, we'll talk more about these gorgeous images and how these clouds look up close. I mean, these are structural 3D dimensional clouds there that look like a Van Gogh painting. You can't make it up. All these swirls and storms going on as the clouds are whipping around Jupiter at over 1,000 miles an hour. Though it's the largest planet in the solar system at over 80,000 miles in diameter, the Earth is just under 8,000. It has one of the fastest rotational speeds as these clouds are whipping around every 10 hours around this gigantic globe, something we still don't understand the why of. Well, we're going to Jupiter in the morning sky and Venus to our evening sky. And here's what our evening sky looks like. You're going, Mark, it doesn't look like much to me. I can't see the star patterns. And it's hard to depict on when you're looking at something on a screen. So we'll outline them for you there. And this is our Stellarium program that I recommend you get. Stellarium.org, a free planetarium on your computer or in your pocket. You can download Stellarium for your smartphone, and then you just hold it up. And there's a lot of apps for that. There's Android and Mac apps for all that. So just go to your app store and download one of those and start learning where the planets are and the different constellations. Well, up there at the top, you see the Big Dipper standing on its end. And as we arc that Big Dipper handle, we arc to Arcturus, a bright star in a constellation that looks like an ice cream cone or a kite. It's called Pleiades, and that's Arcturus. We outlined it there. And Spica is the next bright star. The only two bright stars you're going to see in the east after sunset are Arcturus, the third brightest star in the sky, and Spica there. So I was looking for my notes on the constellations there. Okay. Arcturus, let's look at the stars of the Big Dipper. Okay. Here we go. I got my cheat sheet here. The stars of the Big Dipper are more than just the 7 stars of the Big Dipper. Ursa Major, the Big Bear, there you see it traced out, and his nose would be on the far right, and at the bottom you see are the stars that make his legs. But the Big Dipper's its hindquarters. And it's interesting to look at these stars from left to right. They're all named. They have names that were basically given by Arabic. All right. Interestingly, many names of stars have Arabic names from the Arabic astronomers of Mesopotamia, Saudi Arabia, Egypt. But the constellations have Roman or Greek mythological names. Okay. Let's see, from left to right, Alcade there is a blue-white star 100 light years away, and it's just about second magnitude. Most of all the stars of the Big Dipper are what we call second magnitude, on a scale of first to sixth magnitude being the faintest stars you see. In the astronomer world of magnitude, the higher the number, the fainter the star. The lower the number, the brighter the star, and we even get into negative numbers. So we've got the Alcade is there at the end. Mizar and Alcor are a double star in the bend of the handle of the Big Dipper. They're 80 light years away, and you can see these with the naked eye if you got good eyesight. Next is Alcade is in Merrick and Dubé. The hind stars of the bowl are Phecta and Magritte, okay? And all these stars are about 80 to 100 light years away. meaning we're looking at these stars as they appeared 80 in 1940s is when the light left these stars, okay? And they're hitting our eyes now. So they are like the Pleiades we saw, this was a tighter cluster of stars that grew up together, born out of a cosmic cloud like the Pleiades, and now millions of years they've moved further away from each other. The two pointer stars to Polaris up there at the top, the North Star, are Dubhe and Merak. And Merak is 79 light years away. It's 3 times bigger than the sun, 70 times brighter. All right, so if it was a lot closer, it would be much brighter. And Dubhe is an orange giant, 120 light years away, and it's 400 times brighter than our sun. So if these stars were closer, they would shine a lot brighter in the night sky. But the Draco, the dragon, arcs around between the Big Dipper and the Little Dipper. But these stars never set, and right now the Big Dipper, you can tell time by the Big Dipper as it moves around every 24 hours. But right now it's standing on its end in the night sky. There's the picture I was looking for as we talked about Alcade. And Mizar and Alcor are the double star in the bend of the handle. Alioth, all right, a blue-white star 81 light years away, 4 times bigger than the sun. There you got Magritte and Phecta, and Dubhe and Merak. And for example, Mizar and Alcor were known as the horse and rider. And again, it was a test of eyesight if you could split those two. Now, they just look close to each other. They're not what we call double stars orbiting each other. So the Big Dipper, the stars have names. There they are. Learn them. It's fun to learn them. Particularly at my age, it's more fun to learn them to keep that memory loss at bay. So the Big Dipper can be used to find all kinds of other star patterns in the sky. And you go from the Big Dipper to the east and you run into Regulus and the backward question mark of Leo the lion with the triangle of the hindquarters on the back there. But when you take the handle of the Big Dipper and you'll arc to Arcturus in the constellation Bootes, and then you speed on to Spica. That's a little phrase that I've learned when I was about 10 or 12 years old. Read it in a big astronomy book. Arc to Arcturus, speed on to Spica. And I've remembered that and told that to thousands of people under the stars so that they can remember the names of these bright stars in our eastern sky rising right now. Bootes is an interesting constellation. It looks like a kite or a ice cream cone, if you will. It represents the herdsman or the plowman, all right? And in fact, Arcturus, there at the bottom, is a supermassive star, 3rd brightest star in the sky, okay, behind Sirius, Canopus, and then Arcturus. And the whole constellation is the home to 5 stars have confirmed planets in it, okay? So we're now getting to the point where we've discovered over 5,000 stars in the sky. I mean, over 300 to 400 stars in the sky that have over 5,000 planets orbiting them. And some of these stars in this ice cream cone or kite shaped of Bootes have confirmed planets orbiting them. And as you speed on to Spica there on the bottom, Spica is the most luminous star in Virgo, very indistinct constellation. That's why you just look into the void of the east and there's just not much there. Okay. But this is about the same size as our sun and about the same brightness, okay? It's bigger than our sun, but it's 37 light years away, pretty close. So and Arcturus is an ancient Greek name for guardian of the bear, with the star found at the herdsman's left foot. And as he follows around the bear, he's guarding the bear or herding the bear, maybe. So these ancient constellations, where the names came from, Boötes, of all the interesting names I've heard out there, never heard anyone called Boötes, Marty. Maybe I'll start a trend here. Be a good name for a cat, all right? Or Arcturus, great names for animals, and maybe not your kids, okay, are in some of the star names of space. Let's look at Virgo real quick. Let's look at Arcturus real quick, and Boötes as we're talking about it. Its main stars also have names, okay? The Alpha, Beta, Eta, Gamma, Delta, that is the Greek alphabet. So one of the original ways that they classified stellar brightnesses of stars was by just the brightest is Alpha, the next is Beta, Gamma, so on and so forth. The Greek alphabet is how you would go down. So usually that's the case on constellations. They named them after the Greek alphabet, but sometimes the Alpha star isn't the brightest star in there. But there you have the two stars on either side of the triangle, Mufrid and then Zeta. Neckar is the name of the star at the very tip of the ice cream cone or kite shape of the constellation Boötes. And so get out there and Arcturus and speed on to Spica. And the summer sky is coming up right behind there. This, frankly, is kind of one of the boring times of the year where you don't have a lot of bright stars. And you can see things with your binoculars. A few of the galaxies that are in Leo and Ursa Major and Virgo are visible. But those are basically the realm of telescopes out there. So, Marty, something very interesting happened over the weekend that was just a jaw-dropping photograph taken on Mars by remember the helicopter on Mars that was supposed to do just 5 test flights, cost about $20 million, I think, would sit on this table I'm in front of here called Ingenuity that was under the belly of Perseverance when it landed in February this year on Mars. Well, it's roving around. The rover's doing a good job roving around, but Ingenuity also keeps flying around. And on a week ago, it made its 25th flight, and look at what it saw. There it is flying around. What is so amazing about this helicopter is the rotation of these blades that are about 4 feet in diameter, and the whole thing's less than a foot across the box of it, have to go over like a crazy number, like 2,000 revolutions a minute. And the atmosphere of Mars is only 1% of what the Earth's is at the surface. 1%. This is less than what's on top of Mount Everest, 6 miles high, okay? So there's no breathable air. It's all carbon dioxide anyway. And to sustain, is enough atmosphere to sustain dust devils and frost and clouds, cirrus type clouds. But they got this helicopter working, and it won't quit. All right, it's powered by not batteries, battery powered by solar cell on top of it. So it's solar powered, so it can last, until something really, really fails. But they, as they've been doing and pushing the test further and further, and this is not a photograph, this is an artist's depiction of Perseverance in the background. So it was going by inching closer and closer, Perseverance was, and they like landing Ingenuity close to Perseverance, just kind of a home thing, and then the communication pattern's good. So I've been using Ingenuity as surveillance for places for Perseverance to go. And they said, well, we're close to the debris that was strewn on when our back shell hit the ground and the parachute and stuff landed. Let's go take a look at that. So this is what you're looking at. This is so interesting. This is the back shell that contained underneath it the flyaway sky crane that landed, that flew the rover over its landing site and then lowered it by a skyhook to the surface. This shell separated, and there you see at the top is the parachute that helped land this whole thing. All right. And here it is. And what an engineering marvel for people at Jet Propulsion Laboratory, because nothing better than to see something broke that you put together and how the pieces fell apart, what was the strengths. This was not designed to survive the landing on Mars. It was designed to be disposable. But it hit the ground at about 80 miles an hour, according to NASA, and strewed debris everywhere. And there you see the surface debris in that. The parachute in the back still has the lines attached to it, all right? And this separated out from the parachute, and below it was the rover and the sky crane with a jetpack on it that flew away. And here's a close-up of it. This is from the helicopter that was only supposed to last five demonstration missions. On its 25th flight, it took these incredible images of the spacecraft that brought it there. Okay, there you see at the top, Marty, at the very tippy top is the rope attached, and the rope is going off to the right there. What an engineering marvel. They're looking at springs and pieces that were smashed, and they're probably saying, hey, that held together pretty good, you know. And it landed, you know, it didn't fly around too much because there's not much atmosphere, so it landed straight down. So incredible. From 33 feet high is where Ingenuity was. It has traveled over a half a mile at about 13 miles an hour on 2 to 3 minute flights, and it did 2 more after this in another region. So, but just an incredible jaw-dropping photograph that I'm happy to share with you if you didn't see it over the weekend. And here is Mars. Oh, we didn't have. Wait. Oh, I took it away. There's Mars in the background, and there's the aeroshell separating. Okay, you get the idea. The white aeroshell there, as you see it right there. Now you get an idea of what I'm showing you. That's separated. That ring was a reentry part that came out. They still have the rover attached underneath that shell because the next phase is for the parachute to come out of the top up there. So isn't that amazing? There it is. Of course, this is an artist rendering of it. That's not a photograph. With the planet behind it. That's the Syrtis Major dark feature, and the arm at the bottom is Sinus Sabuus, and you see some cratering there on Mars there. So, well, hope you've all enjoyed a little bit of Star Curious on Stay Curious with me, Mark Marquette, and Marty Winkle. Thank you very much for your help today. Hope you can all get out and see Mercury and near the Pleiades and the crescent moon tonight. But watch that moon dance going across, all right, as the moon is starting to now go from new phase to first quarter phase. And I'm going to get my star wheel out here, charge up my red light. And Dave Stange, hope you get out and do some stargazing. When the moon's not out, my battery's just not messing up here. I'm going to dilate my pupils. Well, there we go. Going to have to clean these contacts off. That's something when you do use electronics outside, you need to make sure those battery connectors don't get a little corroded on there. But thank you, Carlton Bailey, for watching. Dave Stange, Robert Law, Tom and Mark Usiak are watching. Bennett Scarborough, thank you for watching. Flag of the Man is on there. Mikey Haddad, thank you, Mikey, for watching. We will stay curious with Mikey Haddad, Thursday, as he's going to bring us Shuttles of the Month. And Ya Ultra Renolves, okay. And I'm going to have to have Marty start interpreting these names for me. But we don't care where you are, Ya. We're glad that you're watching us and staying curious, along with so many of you that become regulars on our program here. So, yep. And tomorrow, we're going to stay curious with the one and only voice of NASA, Mr. Hugh Harris, and tell us about the Shuttles of May coming up. So we look forward to that. Once again, thank you, Marty Winkle, and thank you, everybody at the American Space Museum. I'm Stargazer Mark, and we can't wait to see you in our museum to stay star curious and bridge the space between us.